Another example from 10.4, number 44. We have the stopping distance in feet on wet concrete at a speed v in miles per hour. So this is the stopping distance in feet at a speed of v miles per hour. It's given by this function. Right? So this tells us how many feet it takes to stop on wet concrete at a certain speed. And we're only using stopping distances greater than 0. We're not going backwards, okay? And the question is, at what maximum speed could a car be traveling and still stop at a stop sign 44 feet away? So if we let the stopping distance be 44 and put that into this function, let the stopping distance be 44. So we're going to plug in 44 for the stopping distance at time v, and then solve this equation for v. That's all we're doing. We're solving this equation for v. So we want to put it in our nice familiar a v squared in this case, plus bv plus c form. Right? It's not in that form, so we change it to put it into that form. Just subtracting 44 from both sides of this equation to end up with this equation. So now it's nicely in our familiar form of ax squared plus bx plus c, which is v instead of x. Doesn't make any difference. So now our a value is 0.055, right? 0.055. Our b value is 1.1. And our c value is negative 44. So as soon as we got that, we're just solving this equation for v. We use the quadratic formula. Right? Negative b plus and minus b squared minus 4ac, all of that over 2a. And we carefully calculate those values. Underneath the square root sign here, you should get this number, 10.89. 2 times 0.55 gives us 0.11. Then we split this up into two fractions. This number over the denominator gives us negative 10. And this number, if you calculate that, you get 3.3 rounded to one decimal. 3.3 over 0.11 gives us 30. So we end up with negative 10 plus and minus 30. We throw out the negative value because we're not going backwards, and we keep the positive value as our answer. So our answer is 20 miles per hour is the maximum speed that we could be traveling and stop 44 feet away. Okay? We just plugged in 44 for the stopping distance, manipulated our equation to get it into the form that we wanted, and then we used the quadratic formula to come up with our answer. All right? So that's the last example from 10.4.